Alright, this is video 7 for College Algebra. We're going to be talking about inequalities and absolute value inequalities today. So first, we're just going to do some basic inequality and absolute value problems. So for this first one, we're just solving for x. Alright, so when we solve this, we would want to get everything with an x on one side, everything without an x on the other. And remember, when you divide by a negative, you would flip your inequality sign. So we get x is less than 2 whenever we solve this. And don't forget, with inequalities, we have to draw a number line. So here is 2. And our number line, this is an open circle because it's a less than. And we're going towards all of our smaller numbers. Okay, for a problem like this, remember we're going to have to do, when we subtract 7, we'll have to do it from the middle and both ends. So it would be minus 7, minus 7, minus 7. All right, and so here we'd get negative 6 is less than x is less than 4. All right, and then when we divide by, and this is still negative 2. When we divide by negative 2, it flips our signs. So we have, this is our answer, but it's a little bit easier if we rewrite this going from smallest to biggest. Okay, it's just a little bit easier to read. And so when we are drawing this, we've got two open circles at negative 2 and 3, and it is colored in the middle, shaded in the middle. That's our solution set. All right, for number 3, we need to get our absolute value by itself. So first we're going to add 2, and then we will divide by 3. So now we have our absolute value by itself, and we can split this into our two separate equations. X plus 4 equals 3, and x plus 4 equals negative 3. So we've got x equals negative 1 and x equals negative 7. All right, so those are just some examples of inequalities and absolute value. Okay, and now we're going to kind of combine those. So just a reminder for our graphing. We've got our set notation and our interval notation. Okay, and we'll have to write our answers probably like that. Remember what our graphs look like. A line underneath means it's going to be a closed circle. So if it's an or equal to, it's a closed circle. If it's just a less than, it's an open circle. Sometimes you might see your graphs like this with brackets and parentheses instead of closed and open circles. They mean the same thing. Okay, so here's our little key. Less thans and greater thans are parentheses and open circles. Less than or equal to, greater than or equal to are brackets and closed dots. All right, this next part is what do we do when we're solving an absolute value inequality? So the first one, if it's set up like this, with our absolute value being less than some number, this is our interval, okay? And that's how we would set it up. If it's less than or equal to, same, we just add the or equal to's. If they are greater thans, we have an or statement. So these are compound, these are and, these are or statements. So we'd have two separate statements. And so this little piece of information right here, this 4 statements, is key to solving these. It'll be really hard to solve these inequalities if you don't have this memorized or if you don't refer back to it. All right, so to solve this, first make sure we use the chart to make our inequalities. So here we have an absolute value less than a number. So if it is less than, we're going to have an and statement with negative a and positive a. So we can rewrite this without our absolute value bars as a compound inequality. All right, so we made our inequality. Now we just have to solve. So we add 5 to all 3 sides. And we have 3 is less than x is less than 7. Okay, and step 3, we need to graph. And I make my graphs very simple. I just put the 2 points that I need. Okay, and they are open circles, and so we are shading in between. Again, we could make our graph with parentheses at 3 and 7. Sometimes online textbooks would rather prefer this second option. All right, so that's our first absolute value inequality. Our next one, we've got an absolute value is greater than 7. So greater, it's an or statement. So it's going to be this last statement because it was a less than or equal to. So we're going to have a 2 or statements. So we can come over here, we've got x plus 3 is greater than or equal to 7. And let's write our negative first. So this will be negative 7, or x plus 3 is greater than or equal to 7. All right, so I subtract 3, x is less than or equal to negative 10. Subtract 3 again, x is greater than or equal to 4. All right, so on my number line, these are brackets or closed circles. And this time let's do a bracket. This is at negative 10 and at 4, and we are going on the outsides. Or statements will be on the outsides. All right, so now we've got 2 more examples, but this time we're going to be talking about polynomial inequalities. All right, so I've got the steps written out on the left-hand side, and we're going to work the problem out on the right. So step 1, set equal to 0 and find all real roots. Okay, so for this, we can factor, and I know it's going to be x minus 3 and x plus 2. So when I set each factor equal to 0, I know x equals 3 and x equals negative 2. All right, those are our key numbers, okay, our roots. So we're going to put them on the number line and find test intervals. And this is where it gets a little weird. So I've got negative 2 and 3. All right, so we have to find our test intervals. So these are our test intervals, negative infinity to negative 2, negative 2 to 3, and 3 to infinity. So now it's our job to find a value inside of our interval and determine if the graph will be positive or negative. Okay, so I like to find easy numbers. So first, let's just try x equals -3. That would be in this negative section. And you can find your value can be any number less than -2. Okay, but I'm going to use -3. So plugging this into my equation, this will yield 6, which is a positive number. So in this section right here, I've got a positive interval. Okay, so now I want to find a number in between -2 and 3. So I'm going to use 0. 0 is easy to do. This would yield -6, which is a negative number. And lastly, I'm going to choose 4. So essentially, we're just plugging in numbers into our equation and finding out if it's positive or negative. Okay, and over here we've got 6, which is a positive number. All right, so far we're almost done. So now it says if it is greater than, we want positive intervals. If it's less than, we want negative intervals. So we want to find the negative interval. Well, that's right here between -2 and 3. All right, so our answer in our interval notation, we can write it 2 to 3 using those parentheses. And we're actually going to draw our number line from -2 to +3. That's our shaded area. Now again, if you want to write set notation, you can. It's just a little more tedious. All right, so let's do another problem. All right, x squared minus x minus 20 is greater than 0. So first we set equal to 0, and we will solve. So I know it's going to be x minus 5 and x plus 4. So x equals 5 and x equals -4. All right, so we make our number line, put our key values on, which would be -4 and 5, and then we need to test some values. So I'm going to test -5, so -5 squared minus -5 minus 20, and that's equal to 10, which is positive. So I know in this interval we have a positive value. If I test 0, if I can test 0, I'm probably always going to use it just because it's easier to do the math. So this equals -20, which is negative. And I'm going to go ahead and test 6. And that is 10, which again is positive. All right, so here we want values that are greater than 0. So greater would be these two positive sections. All right, and so this would be from -infinity to -4, and that connects to 5 to infinity. Okay, and on our graph, we've got open circles, and we are coloring the ends. Okay, and that would be our solution set. So here we've gone over inequalities with polynomials, absolute value inequalities, and again, these rules will help you solve those.